Ok, vedo che sta raggiungendo il palco.
Eccoci, scendo.
Roman Zhukov. Ecco, Roman, il palco è tutto tuo, go.
All right. September 2025, just 2 months ago, Shai-Hulud. This is the fancy name for a worm that actually poisoned about 500 NPM packages, which is popular open source ecosystem used by the millions every day. And the interesting thing about this worm was that it was self-replicating worm that actually was doing a lot of bad things, including the stealing credentials and etc. And also it uses open source tools, for example, TruffleHog, for gathering tokens and passwords from others. It is your open source, guys, not somebody else's. Welcome back. Buonasera, signore e signori. I'm so happy to be here. I'm Roman. I came from Ireland, the original home for Guinness, Jameson, and all of this good stuff. I work for Red Hat as a principal architect and leading our security community engagements. But I have been doing security for almost 20 years. Previously, I was head of product security team at Intel, responsible for Intel's data center software business unit. And that's why I will be talking about how Intel gets hacked a little bit, which is fascinating. But also, I'm contributor to open source. If you're familiar with the communities like OWASP or OpenSSF, I'm contributor and maintainer of a few of their initiatives. And at the end, we're going to have some fun activity, a little quiz, so just stay up until the end. And the usual disclaimer, all the opinions are my own and don't necessarily represent the views of my current or previous employer. All right, how to hack and defense open source. So that's going to be in 2 parts, hacking part and defense part, and of course a lot of open source tools and useful frameworks that you can get right away and use in your work or your life. Now, do you use open source at work somehow? Do you use? Okay, I see almost everybody uses. Others who didn't raise their hands, probably you just don't know it yet, but everybody uses open source. The whole world runs on open source. And I got some statistics for you. This is the relatively fresh analysis risk report by Black Duck, which says that, yeah, this is pretty much around the 100% of the code bases contain open source, which is good. And it's used, of course, everywhere by all the companies. On the other hand, we have 86% of the code bases contain at least one vulnerability, right? And 81% of the code bases contain high risk or critical vulnerabilities, which is reality we need handle. And also it contains maintenance and operational risks. 91% of code bases contain outdated open source components, right? Which is, again, reality. We just should admit it and somehow handle it. Now, why it is important? Because when it comes to open source and specifically how open source is used in developer environments or IT environments in the companies, I like to kind of present this simplified diagram which represents the usual development workflow from the source code to build, to deploy the package, and straight away to production. Now, what could possibly go wrong with this? Actually, a lot of things. Pretty much in each stage, we can have some sudden security failures. Bad code could be submitted, source control could be compromised, malicious versions, build systems, and so on and so forth. There are a lot of things. And we have been talking about these things for quite a while, why it is important now. because it's still exploitable. It's still happening every day, all of these hacks. And now, with the power of AI, we actually see the increased speed and increased attack surface eventually. Now, let's talk a little bit about the actual risks, right? Why, again, it is important, and what risks could it impose? And this is top 10 open source security risks. If you're familiar with top 10 frameworks by OWASP, they actually do not only top 10 for the web, but top 10 for a lot of different things, including Gen AI and etc. But this particular is for open source risks, and you can see them from known vulnerabilities all the way down to license risk, of course, is a huge one, inappropriate change, and etc. There's a link. It's all, of course, free and open source. You can check it out just to be aware what risks are typically comprised of the top 10. Then leads to the hacks, the actual hacks that we are going to explore just in a moment. And now, from security risks to security attacks, this is the first one. These attacks that I'm going to show you as the public examples, but I deliberately pick the top 5 because I witnessed them all in my career working for a different company, so they are real, they are happening. The first one is dependency confusion. And this example of the dependency confusion that npm install analysis PayPal, that actually was the dependency that mimics the actual PayPal open source projects that then led to DNS requests to command and control malicious server. So then it got deprecated, but it was ingested by quite a few people. So the second one is typo squatting, and I think there was there is another rise of this with all of AI tools and LLMs and AI models specifically that we kind of download all the way down from the Hugging phase. And this is one example, Eleuther AI instead of Eleuther AI, right? Spot the difference here. This is fake LLM model that was added to Hugging phase that contained actually malicious code in it. So typo squatting, another like popular technique to hack or to ingest something malicious into the open source. Trojan injection, another one, is quite popular again nowadays, and I witnessed a few attacks myself and mitigated them for this one. Are you familiar with Dependabot? So this, quite a few of us, this nice tool that bumps up automatically dependencies for our software. For example, this is default tool is used in the GitHub, right? Which you can use for free if you kind of manage public repositories. So this Dependabot actually was malicious one, and it commits. We typically trust these tools because they are kind of good ones, and I encourage everybody to use automatic dependency updates. But this was the malicious one that pull requests that accepted contains info stealer. So steals basically your info, credentials, and etc. It was quite a big one and still persists nowadays. I mean, these types of attacks. Now, repo or package hijacking. This is one of my favorite one because in the world of open source, we have all of these repos and package managers are free for use to everybody and actually almost free to post anything because it's open source, right? It's right to publish anything that you want. And in this particular case, Koa is the popular command line tool that was hijacked over npm account takeover, right? So there's basically the steals account. And that's particularly relevant in the world of AI as well, when I constantly see the model hijacking. And I was surprised when I kind of investigated this topic, how easily, at least until the recent days, it was to actually take over the unmaintained AI model in Hugging Face by basically filling the request and then turn or input something malicious into it and then still have a user base for it, right? It gives you, like the huge opportunity to spread the malware or malicious code. And finally, developer environment compromise. This is quite interesting one, especially when it comes now to wipe coding and to the IDE tools like Cursor, VS Code, and etc. that we all use, right, or most of us. And this is a great example that I like. You see this Dracula face here. This is particular was related to VS Code. There was an extension, Dracula Official, that was so popular, over 7 million installs. Right, but that was replaced by the malicious one that's similarly looking, and it was extremely popular, right? At the trending section of the plugins. And nowadays, I see, unfortunately, how fast developers are including all of these extensions and trust them blindly, right? Just because they say, okay, this is like. Install whatever by default or clicks the box. There are a ton of them, right? So that's quite a popular technique how to hack open source as well. Now to other top 10. Actually, this is the recent one, I believe, released not long time ago. This is top 10 CI/CD security risks, because besides the source code, a lot of companies that get hacked, we are CI/CD systems, right? And I will show you a few examples later on, but this is very important to understand that your CI/CD systems, your build systems is actually could be compromised, and especially when it comes to the open source development. A lot of companies, from big to small, they develop in the open. Right? And there is, of course, connection between the open source repos and the internal infrastructure of the company. So that's why it's really important to understand top 10 CI/CD security risks. Now let's try to move on, if we can. But we can't. Okay. Hopefully it's going to be fixed, but again, this is super important. And while we are fixing the slides, changing next, I'm gonna be talking about the hack, about the Intel hack, and this is specifically related to some of the CI/CD issues. Now. Still not working, but that's okay. This is what typically happens in the live demo. I actually was considering to bring up some live demos, but then I thought it's not going to work, but slides should. Okay, I'm going to start with a story. There was a typical Tuesday at my work, and and I was logging in to our internal developer system at Intel that we had actually. And let's put this a few slides back. So yes, the usual Tuesday morning, and at Intel, as I mentioned, as well as the big companies, we have this open source development, and we reuse actually open source development practices internally, and we had internal developer tool suite that is also called inner source, when you do open source style development but inside the company. And this is one of the kind of Intel inner source stuff. So that was a usual Tuesday morning, but when I logged into this, I saw pretty much this. Defaced internal system, right, in front of me in my computer, and I say, oh wow, that's cool. That says, okay, the hackers are here, in internal Intel system, which is not good. And I was on the security team. You can imagine the nightmare of all of these things. Now, what happened? Now it's public story, and you can find the disclosure of it as a recording at the Black Hat conference. These two people, actually researchers, and we were so lucky at Intel that this hack was done by researchers. We, of course, kind of paid all the credits to them, but you could imagine if it's the real hack, because they got the access to repos. And, of course, this is a usual kind of thing that they have not accessed like real critical stuff inside, but they got an access to pretty much a lot of repos internally, which is bad anyway, right? Which is confidential, of course, and they kind of got these admin permissions so that they can make all the internal repos public because they got the GitHub admins. Now they actually posted some of the cool stuff about the royal core intellectual property. As I mentioned, there was nothing really super critical, but still they got an access to some internal stuff. So that was interesting learning, and that is how it was happening. Again, it's all in public, so I'm not really disclosing some of the confidential information, but this is interesting case. So how it exactly happened? We have the developer, right? Whether it's internal or external developer to the company, it doesn't matter. Now we have this cloud-based software development platform like GitHub, GitLab, you name it, right? Like a lot of us use all of this. And developer usually push using the REST API, push some commits to it, and it's communicate to the Git repository. And GitHub Actions comes to play here. GitHub, GitLab, and all of these platforms, they allow to run CI jobs and provide some curated runners at the marketplaces. So basically, you can go to the marketplace of this and download some of the actions, some of the runners that can help you with automation, like out of the box, which is good, of course. Now what happened next? This kind of public connection was this publicly facing repo actually got the connection to internal stuff, because at a lot of companies we also wanted to run some of the tests inside. Specifically for the hardware platforms, of course, we don't expect that all of the CPUs exist, for example, on the public GitHub, right? We use our own bare metal hardware and our internal instances, and that's why we need this connection between the open source repo and the closed behind the firewall CI/CD system. Now that is how it works, and this is where self-hosted runners come to play. All of these systems, as I mentioned, they allow us using self-hosted runners as opposed to use these public runners from marketplace, which is quite convenient because you can use it internally and you can configure them whatever. But it's also important to understand this notion of ephemeral runners because these internal runners and all the runners, actually the good practices, they're supposed to be ephemeral, like run one job at a time and then disappear so that it couldn't be hijacked, it couldn't be taken over, right? But it's not happening all the time, of course. We are all lazy developers and sometimes don't pay attention to security things. And with these self-hosted runners, that is possible to actually establish the malicious one or non-ephemeral one that are not stick to the one job. And another thing important to understand within this case that once you have this whole setup with a publicly facing GitHub repo and internal instance with the self-hosted runners, you can actually put the PR as a kind of public random person, and once it's accepted, you become a committer, and you have permissions within this, with this GitHub repo. And then, if configured non-properly, it could allow you for the second and subsequent pull requests to do some malicious stuff internally, to push some jobs and to push some malicious code into the jobs that then are run internally, which exactly what happens with Intel. So this kind of potential attacker have done the malicious push, and the malicious workflow was triggered. It's quite small here, but it's actually also based on the notions of pull request target. If you're not familiar, pull request target, this is the specific command that allows to use and pass some secrets, tokens, and etc. And because of this, that was possible to make this kind of malicious activity, and then this malicious attacker exploited the self-hosted runners to make it malicious one, to put some malicious code, and then runner checks out the attacker's code and get the access to the repository. And if this malicious code contains something like a reverse shell, for example, to be able then to get access to the command and control server, here we go. You can do whatever you want with internal infrastructure, and because pull request targets allow you to use the secrets were stolen, and so then you can get the permissions of that user and then possibly elevate these permissions, and that's what's exactly happened. So that's all connection from open source to internal infrastructure is quite dangerous. Now, how do you typically choose open source, right? What could this story tell us? So this is another example, and this is based on the TJ action, which is quite popular tool as well. This is the actual action in the marketplace. I brought this example so that to give you understanding, even if you use the marketplace-based GitHub Actions, it's not 100% secure if you don't pay enough attention and don't do security control. So this is extremely popular, used by a lot of people and a lot of stars. And what could possibly go wrong with it? Yes, a lot of companies actually use this. At the time of this incident, we at Red Hat, we didn't use this, but a lot of companies actually use these TJ actions because it allows to track the changes in the files when you, when you manage your GitHub repo and do the builds, which quite handy. And that was hacked. This TJ action was hacked through the notion of the imposter commit. You can again find out a little bit more. That was fully disclosed at Black Hat again in 2025, I believe. And the malicious imposter commit is that is actually non-existent, like ephemeral one. And this is so nice that they were able to use these to also implement some of the malicious code into TJ action. What exactly happened is here, right? So TJ, yes, C runner execution is the first step that invokes the download memory dump, the Python script over there. Now this the script is executed to grab in for some secrets, which was actually the main point of this attack. So they got the secrets from all of these companies that's used TJ action. They double encoded secrets using base 64, which is quite interesting because it kind of helps to avoid masking in logs and etc. So no non-proper encryption, but kind of nice encoding, and then it prints results to the workflow log, and then it used and then it exfiltrates public secrets and send them and let attacker to use these secrets. So that's another example of how it could be hacked. Now, to summarize this, how to hack open source in general. Be curious, of course, but also you can use this. I like this repo because it contains a lot of offensive tools, and of course connected to AI as well. A big catalog that is quite nicely organized by, for example, extraction attacks, poisoning attacks, evasion attacks. So it's quite nice. Quite obviously, there are a lot of commercial tools, but why don't use open source? So you can use these offensive tools to test, to do your teaming exercises, which is quite nice to understand and to help you get prepared to the next possible hack to your company via open source. What else you can use? This is another brilliant example that I like. This is another open source repo which called Select to AI extension, which is kind of nice naming. And what could go wrong with this open source repo, could you ask? Actually, this is the malicious content in this repo, specifically the malicious executables like named like a WinRAR and CMD.exe. It contains smart loader and etc. And this is kind of quite nice. There are a lot of, unfortunately, open source repo out there with malicious content in it. Why I'm showing it? Because this is the open source malware.com website, which is quite good for you to understand what is the current state of the malicious open source malware in the certain repos. Basically, it is good practice to go to this website and check first whether this repo is good that you're gonna use, but also to understand better how these attack techniques are working in practice. So I would suggest to go and check. Of course, it's completely free. So yeah, this is very good source for you to hack open source, or at least to understand how it can get hacked. Now, defense frameworks and tools. The second part, because it's quite important to understand what we're going to do with all of these hacks. And first of all, I would like to show you this one. Is this S2C2F framework that is built originally in Microsoft, but now this is hosted under OpenSSF. And this is quite good for all of their organizations that actually use open source to understand the whole life cycle of these. There are 8 practices dealing with open source, all the way from ingestion to inventory, update, enforce, audit, scan, rebuild, and etc. And I like this framework because it's super practical. It gives you good recommendations what to do. For example, let's pick up the one like minimum OSS governance program, right? Probably you need to do your inventory of open source software, like doing SBOMs and etc. Basically know what you consume. Still, a lot of organizations that I talk to don't know, right? What kind of open source they use, and etc. etc. So some of the good practices, which is awesome. Now, what else you can use? This is a security baseline, or OSPS, also under OpenSSF. OpenSSF, this is Open Source Security Foundation, which I am a contributor to and maintainer, one of those projects. And specifically, security baseline is the set of good practices. It started with the security practices, right? But it ended up with the, I think, 8 areas of security practices, like from access controls, but it also includes legal and quality and etc. They're just good practices that all the developers hopefully are using today, right? But it's of course free and open source, and one of the example of the practices this: when a new collaborator is added to your repo, and again, it's whether internally or externally, it's agnostic. It could be implemented inside the companies as well. When a new collaborator is added, the version control system must require manual permission assignment. This kind of makes sense, right? You don't want it to just give the random new contributor all the rights and permissions. So there are, there are all good practices ranged by the by the 3 levels. You're going to check it out. Again, it's originally made for open source and it's applicable for open source development, but it could be mapped to the in-house development as well. Another good set of frameworks that is useful is OWASP Secure Pipeline, and it's just actually released, I think maybe a couple of months ago. This is also completely open source and free. It specifically targets pipelines. Remember, I mentioned the CI/CD security risks and those kind of hacks, how via CI/CD pipelines and the general DevOps process, companies get hacked. This is the framework that helps you to get prepared. And there are also 3 levels from foundational to advanced. And again, this is all contains good practices, right? And they are kind of really practical and developer-centric approach, which is the key actually to success in the security programs. Because if it's something like policing, or if it's something came from the regulation and don't necessarily developer-friendly, it's not going to be implemented at that quality that we as a security people expect to be implemented. Now you kind of can ask me question, okay, this is all good security frameworks, but probably it's not actionable, and do I need to implement them manually? Not at all. There are a few automation tools, and a lot of them are free and open source. For example, this example shows you how when you choose your open source project to ingest, you want to check, right, whether it's good or not. And this is one example. Actually, key clock here is the kind of piggy one. It's a good project itself because it's the most commonly used and widely adopted open source identity and access management. But I just use this repo for example because it has this small badge that you probably cannot see from the very far. But it says like this project, open source project, implements best security practices, and this is the little badge that kind of attests that it's done right. Also, there is the another good project which called Open Source Security Scorecards, also under OpenSSF, which can give you understanding of the good security practices automatically that are implemented possibly by open source projects. Say you selecting the next open source projects that you're going to reuse inside the company, or you just wanted to compare different projects with the same functionality. How you're going to do this? Remember this example, right? About TG Actions. Probably you can look at the stars, etc. But from security standpoint, you need to have something more. And this is automated way how to do this. The scorecard, if the project uses it, it can gives you a score across just the good security practices, whether or not project implements dangerous workflow, for example, or it signs releases, or what about vulnerabilities in it, and etc., etc. The interesting fact about the scorecard, that's, again, this is open source project itself. Okay, you can implement this scorecard even internally. And we actually have done this at my time at Intel. We implemented scorecard for all of our internal repos to give us understanding how internal developers are doing across these security practices. So this is kind of useful tool. Either you use it to understand security posture of open source projects that you use, or you can even use it internally. And it also supports automation itself, so it can be used as a GitHub action, as a GitLab runner. It also can be used as a CLI tool. So a lot of ways how it's going to be used, and it gives you the nice card that is actually visually looking cool, but of course, all the machine-readable format as an output also supported. Now, how else you can automate it? Another good project is a Minder, and this is, again, all open source, all free to use. this open source project can help you to roll out some of the good security practices that you can plan for your projects. And again, it's first designed for open source, and it's actually used in a few of the open source projects, but it has automation in it. For example, actions to check default permissions in the YAML file, right? So that it's kind of machine readable, and then as you execute your pipeline, it rolls out to to whatever systems that you have, and it implements the security practice. Or, for example, artifact attestations, right? If you do the releases, this is a good practice to make the salsa provenance for these artifacts. So this is kind of automation that, or Trufflehawk, for example. This is good tool to use again, whether you run an open source project or even internally. So quite nice automation for security practices. Again, could be good to share it with developers or kind of try it, use it, and etc. Now, that brings me to the last section. What about AI? I probably didn't mention AI. Okay, only once with this example, right? Or twice, but not all the time. Now we talk about AI all the time. What about AI and how it's related to the world of AI that we live right now? A couple of things. This is the two examples on the left-hand side and on the right-hand side of the similarly looking Claude Code, ChatGPT open source projects. The only difference is that on the right side, this is actually malicious one, and again, this is that's get pulled as an npm package to the npm ecosystem, but it deploys a payload that seeks Claude Code installations on the developer's machine. Quite popular tool, right? Claude. So if this malicious one has got ingested again, it seeks for Anthropic credentials on the developer machines and then set up a proxy between the legitimate API and Anthropic once the developer continues to use Claude Code internally to the command and control server. Okay? And this is kind of could happen automatically because we use this AI-assisted coding tool so natively, so extensively right now, and probably don't necessarily pay attention to what's happening in it. Just because it's popular and it contains like Claude Code, it doesn't mean it's not malicious. This is the one example about AI, and actually this is a nice study that's made by Snyk. And it shows how many vulnerabilities has AI introduced into your code, and the responses was, was kind of very few, right? But at the same time, are you concerned that using AI coding tools will introduce security vulnerabilities into your application? Yes. That discrepancy means that probably kind of it really introduced some of the stuff, but we just don't know about it yet, and we don't pay attention. So that's kind of interesting. What I'm trying to say is that a lot of AI-powered attacks that I see are actually using AI as an amplifier, but not as a really brand new technique or attack vector. Yes, we have the expanded attack surface with MCP servers there and there, for example, but in general, security principles, they remain the same. And that means we just need to use or to implement the good secure development practices and probably extend them a little bit to accommodate the AI world, right, that we are living in. This is OpenSSF guidance on AI code assistance, which I also contributed to. This is actually short and concise guidance designed for developers, not for security nerds like myself, but for actual developers to say, hey, for example, ask the AI to review and improve its own work, guide the AI properly, be security cautious, and This is like TLDR about this, but if you go by the link, you can see the whole guide, and it even contains some of the prompts that developers would want to use when they use these vibe coding tools, right? For example, instead of just, okay, I wanted to create this, this web server database and etc., say, hey, create it in the most secure manner, possibly implements the encryption between all the parties. And by the way, what's about access and management control? I want to use the latest version of it, and I want to be using the latest crypto algorithms, and etc. etc. So this is kind of examples of prompts for each of the risks that are listed here. Quite helpful. And again, this is short and concise. This is not like this size of the book or like this size of the guidance. This is practical, useful, and actually would eliminate at least some of the risks that I showed at the previous examples, right? That is just ingest all of this stuff straight from Hugging Face or straight from, or straight via plugins and etc. without paying attention. And that brings me actually to takeaways about this talk. And takeaways are the follows. First of all, understand where the risks come from you and rinse and repeat. I deliberately showed these frameworks and these curated ones like top 10 because typically we don't have enough time to read like a big documents, but those are really practical and you can try to apply them to your own circumstances and, for example, cross out the risks that are not relevant for you, right? This is quite important. The next one, never stop hacking, and this is open source for everybody, and try to understand how these techniques actually work using some of the tools and websites that I showed you. Automate it with a bunch of decent open source tools that are available for you right now. I still continue to see this misunderstanding that all the good security tools are actually proprietary. You need to pay money for it. Not at all. There are a bunch of open source tools that can help you, right, to automate things, and that can help you to implement developer-centric or engineering-centric security. And AI is attack amplifier. Keep in mind basic security principles and educate others. This is quite important. I got a lot of questions. Okay, how AI is changing the offensive side of security or defensive side of security? Of course, it does to some degree, but the main thing that I see right now, it's an amplifier. It's getting things faster, but the basic security principles are still applicable. Defense in depth, right? Separation of duties, you name it. All of this stuff that just needs to be applied to all of the AI tooling that we have. And if you're curious what's by QR code, this is product security report. This is not like for advertising, it's non-commercial. We do at Red Hat, we do the security reports every year. This is the for 2024, but soon, I think early next year, that would be the next one for 2025. For this year, it contains how we do security practices, CV statistics, what trends do we see, and etc. Maybe quite interesting to see. Now the quiz time. I think that's here what before. For the report that's already mentioned by Black Duck, there is the one interesting section in it that lists the top CWE. CWE, this is the catalog of weaknesses. If you see some of the, actually mostly all of the CVEs, vulnerabilities, they are mapped somehow to the weaknesses, to CWEs. And those weaknesses, and this is top, right, according to 2025 reports, and those weaknesses could be incorrect regular expressions, right, that can lead to vulnerabilities. Improper neutralization of inputs, exposure of sensitive information, uncontrolled resource consumption. What's the top first? What's on the first line? Any guesses? 2025, like this year. Of course, go ahead. Secrets? Anything else? Like AI is here, right? We all do these AI things and all this AI stuff and etc. But the weakness on the very first row. Any other guesses? 2025. Yes. Okay. And yeah, good. Yes, they are all valid stuff, but we still see this improper input validation. All right, guys. Thank you.
Thank you very much to Roman Zhukov for your wonderful, super interesting talk.